with Stewart from Facebook. He will be speaking about how they use open source tools to accelerate life cycle of a release.
Does that mean it's over yet? Hi, I am Simon Stewart. I am an engineer in the London office of Facebook. I joined in November 2012, and at the time there were 13 or 14 engineers in the office. There are now in the region of 150. It's grown by about 10 times. We are still hiring. It's phenomenal. And we do a lot of interesting work. But a lot of the work that I do is open source. And so I'm here to talk to you about like the open source tooling that we have and how it helps us power Facebook on Android. So Facebook and open source. If you go to github.com/Facebook, you'll find there are in the region of 200 repositories. If you were to check out each of those repositories, first of all, you'd be a very, very patient person. Thank you. And second of all, you'd find yourself with the better part of 10 million lines of code sitting on your machine. In the first 6 months of 2014, which is when we last gathered statistics for this, we were in the region of 13,000 commits in the first 6 months. So not only are there a lot of code bases, but they move incredibly rapidly as well. We've got lots and lots of open source. Facebook is a company that sort of, I never realized it when I joined, just how much open source we do. But there's so much stuff. If you're an iOS developer, which I assume none of you are, right? There's React, Shimmer, Pop, KVO controller. If you're trying to do things on the back end, if you're trying to run your service, if you're trying to run Wikipedia, we've got HHVM, Hack, Presto, Warp, Haxel. Lots and lots of shiny, shiny toys for iOS, for your server developers. And the interesting thing here is I've been working at Facebook now since 2012. Almost every single line of code that I have written at this company has been open sourced. Right? It's a strong commitment to open source. It's something that is deeply embedded into the way that we write software and that we behave. Now, I will admit that I am somewhat unusual as a developer at Facebook. But there we go. But yes, we've got all these projects. I'm here to talk to you about what we do on Android. There are some things you may already know about Android and Facebook. You may know that it's a native application after Zuck's amazing declaration about HTML back in the day. You may know that our Android codebase is worked on by hundreds of developers, just a vast swarm of people banging away on code. You may know that Facebook on Android is released every 4 weeks. In fact, that's not quite true. We now release every 2 weeks. We've upped our release cadence. And you may know that Facebook on mobile is used by over 1 billion monthly active users every month. That's a phenomenal number of people. That's a huge reach. And lots of those users are on Android. Android is super important to the company, and open source is super important to us doing Android development. So how do we use open source? I'm going to break this talk up into 3 sections. Source control and code review. I know, exciting, dynamic things that we're all really interested in. Testing and how we do releasing. Source control. How many of you have like lots of projects that you work on? Almost, yeah, a handful of people. Do you put them all in a single source tree, or do you have like a separate repository for each of those? It's a separate repository, right? That's a really common pattern. At Facebook, that's not what we do. What we have is every single one of our Android projects, Instagram, Facebook, Messenger, you name it, live in a single source tree. That's hundreds of thousands of files with millions of lines of code. And, you know, last time I looked at the stats, there were slightly more than 2 commits a day that were landing in there. And when I say slightly more, I mean, obviously, way more than that. It's an incredibly fast-moving code base. And we were originally hosting on Git. And Git was is a fine source control tool, but we were finding it wasn't really scaling to the level of abuse that we were putting it through. Like, it's a huge tree, very fast-moving, lots of people doing things. And so we needed to make some changes. And the change we made was to make the jump over to Mercurial. And the primary driver for that is that we needed to be able to extend the source control tool in order to enable us to move faster and build things on stable infrastructure. So we've been contributing to Mercurial for a while now. There are people in Menlo Park, Durham Goods, for example, who are very active in the Mercurial developer community. We've contributed over 1,000 patches over the past few years. We've hosted the past 2 Mercurial sprints at Facebook HQ. So people came into our offices, the Mercurial development team, sat there, wrote code together. And we've open sourced 2 tools that we use in order to help us move a lot faster. The first is HG Watchman, Mercurial Watchman. Watchman is a cross-platform tool for keeping an eye on changes in the file system. So you can say, anywhere underneath this directory, please let me know what's going on. Because of that, things like HG status and finding out what's changed are incredibly fast, because rather than having to walk the entire file tree, we can just have a look and ask the Watchman what's changed. And so the time has gone for one of those requests from linear to the number of files to linear with the number of files that have changed, and typically that's a very small number. So Watchman and Mercurial together enable you to get really fast, almost instant results out of the back-end system. And the other thing we have is Remote File Log, which is available, obviously, as an open source plugin. And what that does is when you do your HG pull, what it does is it just copies the metadata. It doesn't pull the actual files down. And it only downloads the files when you need to access them, when you do your HG up and you copy those files into your tree. And what that means is that a lot of the common operations are incredibly fast, including your initial clone. Okay? So if you're using Mercurial and you want to go faster, take a look at these 2 tools. They will help. Now, every line of code that we write at Facebook needs to be reviewed, and it needs to be have at least 2 pairs of eyes look at it, the original author and the reviewer. Do any of you do code review? Some people do. For those of you watching at home, it's about 1/3 of the audience. Code review is a really powerful tool to enable sort of shared comprehension of the code base and to ensure that you're not the only one who understands how these things work. And also prevents like utterly stupid things slipping through the cracks. When you're typing, you go like, you misspell a word, and it's like, why isn't this working? It's been like the next 3 days trying to track down that bug, and you go like, oh, it's because I don't know how to spell import or something like that. Fabricator is an awesome tool to help you do code review. I've had the privilege of using a lot of them. This is one of my favorites. You can see here in sort of slightly washed out text, but there's a sort of description of what's going on. Every single review that we put through the system needs a test plan. It's not enough to go YOLO or I don't know, or leave it blank. You actually need to explain how you're verifying that this thing works. And you'll see here that the first review came back with, by the way, I want some changes made. Good, that's very exciting. It's text-based, it's code review. How do we jazz it up? How do we make it awesome? How is it the best build tool in the world, review tool in the world? Image macros. You can put in a single line comment and you get like a little image, and it's mesmerizing. If you don't do code review, start doing code review just for this, right? Fabricator, this is a code review tool that we use. It's open source. Our fork is available on GitHub/Facebook. So yeah, we review code and we store code. Excellent. We've got to build it though, right? And it's kind of interesting. Facebook has to develop as a company a version of our applications that works on the myriad of different versions of Android that are out there. I took some time, gathered some changes. We support from Gingerbread all the way up to the putative L release, which will come out at some point. And each release has done something new and something interesting, right? And so a lot of our open source efforts are around providing a consistent feel over the top of the different Android releases. So if you've got it on a Gingerbread phone, if you've got the Facebook app on a Gingerbread phone, it should feel very much similar to Facebook on a KitKat phone. And so you should have a consistent user experience. How do we do that? The first thing that we use is Quartz Composer, which is an iOS tool. That seems a bit unusual, right? But we've got this plugin for Quartz Composer called Origami, and what that allows you to do is design user interactions and user flows without needing to do a huge amount of programming. And it ends up being quite elegant. You can do very nice, smooth animations, figure out how things should be, get the feel of your application right, because that's the thing that people are going to be using day in, day out, right? The way they interact with your application isn't your beautiful data model. It isn't the elegant structures of your code base. It isn't your command of object orientation. It's them mashing their finger against the screen and desperately trying to get the UI to do something interesting. So having the UI be smooth and slick and nice is super important. We can prototype very quickly using Origami. Once we've built the prototype, there's a library called Rebound. This brings us sort of fun, fast, fluid spring physics. So if you drag down and things bounce or you want to throw bits and pieces around, that works beautifully. And it uses the same physics engine that we use in Origami. So if you've laid out your UI using Origami and you've got like just this perfect way of like flinging cards around, or there's something interesting, a very nice animation, using Rebound, you're going to have that in code. And I think this is the first slide with code in this today. This is what Rebound looks like. It's super simple to use, very lightweight. You can see here we just set up a new spring system. We set some configuration like, hey, how much tension do we want to put in it? And we say, we attach a listener. And then we can change the state of the spring. Listeners are also really, really easy to write. This is the on-spring update one here. And you'll see here that we're just going to be scaling an image, right? So this might be sort of making an image bounce in and out, in and out. There we go. So yes, you've got this lovely UI. It feels fluid, it feels nice. One of the things we take really seriously at Facebook is the privacy of users' data. Like if you lose your phone, if someone takes your phone and they can access your Facebook account, if they can look at your photos, if they can steal your data, that's like a massive invasion of privacy, right? And we want to make sure that your data is secure. Many Android phones have a really limited amount of on-device storage. And so it's pretty common to use like an SD card to store bits and pieces of data. How do you do that securely? We open source a library called Conceal, and Conceal allows you to store data on an SD card in an encrypted form. And it does it incredibly quickly, because what we did is we do the encryption using native algorithms borrowed from OpenSSL, another open source library. If you were to compare this with using a library like Bouncy Castle, you're going to be looking at a speed up of sort of 5 to 10 times if you go through the route of using Conceal. So we can... Symmetric or asymmetric? Is it symmetric or asymmetric? You can decode the data. I can't remember which of the algorithms it uses. But if you go to facebook.com, github.io/conceal, you'll find all the information you need there. I actually work on the back-end tools. Actually, I'm really glad you brought that up. I work on the internal tools team in London. And the tool that I spend most of my time on is our build tool, Buck. Buck is how we build incredibly rapidly. For those of you not familiar with it, which is probably all of you, does anyone use Buck? Anyone heard of it? Oh, you're going to like this. A couple of people. Whose build is fast enough? I'm going to assume it's a round number of people. 0. We ran into this problem. At Facebook, we were using Ant back in the day. This was before I joined. We were using Ant, and it was taking an increasingly long time to make it work. And we were exploring other options. Like Maven required just huge amounts of boilerplate in order to modularize your code base, and we knew that we had the single tree, and that was kind of nice. So that wasn't a great fit, and Gradle didn't really exist yet, and what were we going to do? And so one of our engineers took inspiration from the build tool that Google had been talking about, their internal tool, and built his own. And what we do is basically in each of our packages, we have a build file. And that build file describes just what you need to build this package and its dependencies. And then we read all these build files. We build an acyclic directed, a DAG, directed acyclic graph. And then we can do we can apply computer science to the problem. Like modern machines have multiple cores. They have oodles of memory. They normally have SSDs. Is anyone still using like a hard drive, like one of those little spinning platters of rust that we used to put in our machines? No, okay, that's good. So it's a build tool designed to make use of your modern hardware. And it comes complete with a bunch of smarts, right? So it knows, because we've got this graph of stuff, all the inputs that go into a rule. And because of that, it knows what can affect it. And we treat each thing that we build, a Java library, an Android library, a general, as being a function. So if the inputs haven't changed, we know the output hasn't changed. And so we can skip performing that. DX, the Android toolchain, written by Google, obviously. It's high-quality pieces of software, but they haven't optimized for speed, right? One of the things that we found is that running DX over our libraries was consuming quite a lot of CPU. It was quite slow. One of our engineers took the time out to improve the performance of DX. And so if you're building using Buck, you can use that optimized version of DX and do that. And Java's kind of interesting, right? It's got this model of you compile the class files. And have any of you heard of the ABI, the Application Binary Interface? A few of you have. So the Application Binary Interface is if you were just to take the method signatures of your Java classes, if those method signatures haven't changed, then Java doesn't really care about whether or not you've made any changes to the code itself. If you've added a logging statement, if you've inverted a conditional, if you've done anything like that, it doesn't care, provided your API is consistent and stable. Buck is aware of this. And so if you were to go into one of your core modules, add a logging statement, and do a rebuild, Buck would rebuild that module, calculate the ABI, and then not rebuild anything else other than the final binary it needs to ship, because it knows that none of the linking that Java does is changed. And that allows us to slash build times, right? Because if you change a core module using a normal build tool, like Ant or Make or anything like that, because the output had changed, everything that it touched would ripple through, and that would change as well. It's got smarts around resourcing. We are working on a mini AAPT, Android Asset Packager, just to make things go even faster. And we use Watchman. We use the same Watchman that we use in Mercurial to watch the file system. And we've got a long-lived daemon process that then can, when you say do a build, maintains state, knows what's changed, and does the bare minimum of rebuilding without having to repass all your build files. Just keeps an eye on what goes on, invalidates parts of his model, and it goes incredibly fast. We have hundreds of developers. It turns out, although they're going incredibly fast when they do a build, they're only modifying about 3% of the code base. Like, it's about 3% of the code base is affected by each of the changes they do. And so 97% of the work they do is repeated. What we do is Buck has a distributed caching mechanism that allows us to use Cassandra or HTTP and Memcache to store pre-built binaries from other people. And you remember that if the inputs haven't changed, we treat each of the rules that we build as a function that has the same output, so we can just download it from the cloud. And so we can slash our build times. Typically, it takes an engineer to do a clean build on stable using a pre-warmed cache in the region of 30 to 40 seconds to do a complete build of the Android application for Facebook. And that's a big application. How many of you have a build time of like in the region of 30 to 40 seconds for even a relatively small app? There's a show of exactly 0 hands. Iterative development is also super important, right? You make a change, does it work? Make a change, does it work? Make a change, does it work? Normally doesn't. It's very upsetting. We use a system called XO package, which is part of Buck. If you use it, if you download Buck, you can take advantage of it. What this essentially does is it shards your application up into the core app, the APK that needs to be installed, and then puts secondary dexes onto your temporary file system on your Android device. When you do a release build, obviously we bundle everything up into a single deployable unit so you can ship it. But it's really useful when you're doing iterative development because you can just upload the bits that have changed. Here are some times comparing Gradle and Buck. Clean build on Gradle, 31 seconds. I have no idea what it's doing. Buck, 6 seconds. It's kind of nice. An incremental build goes from 13 seconds on Gradle to 1.7 seconds using Buck. That's a speed up of 7.5 times. A no-op build, because we're using Watchman and BuckD, it goes from 3 seconds walking the file system to 0.2 seconds, so that's a 15 times speed up. Clean install, obviously, first time you build code, first time you ship it to the device, no difference. And incremental installs is where it's really impressive. We go from 7.2 seconds for Gradle, where it basically builds the APK, shoves it across the wire, to 1.5 seconds using Buck. So your incremental builds are incredibly fast. Because your incremental builds are faster, it's easier to experiment. You can have a lot more fun. So, yeah, Buck, awesome. Go take a look. If you want to see how we calculated these numbers, by the way, and verify them for yourself, there's instructions on that URL there, facebook.github.io/buck/article exopackage.html. So you can try it out, have a look, prove it for yourself. So we build it, we have source control, we build it incredibly fast. So nice. We need to verify that this thing works. In the previous talk from Twitter, you heard how they use some open source. And they talked a little bit about the types of testing they do. Effectively, although everyone uses different words for these things, there are 4 kinds of tests: unit, integration, end-to-end, and manual. So a unit test is around the sort of smallest composition of your code, a single class, a single method. An integration test goes like, can I mash these layers together and get something that looks like it works properly? And an end-to-end test is like, well, now I've got my app up and running. Can I poke the UI? Can I get something interesting to happen? Does the network stack work properly? Am I getting the right data back? Does it look good? And manual testing is where you use monkeys. Unit testing. I'm a big fan of TDD. One of the nice things about TDD is, like, we're all developers, right? We are all developers. Does anyone here not write code? Is anyone like a manager or something? Other than like Shelley in the front. Okay, there's one manager. Okay, excellent. So there's a movement in the sort of open source world towards BDD, behavior-driven development, where the idea is that people who aren't developers can read the code and figure out what the test is doing and tell you whether it works. Bullshit. We are all developers. I can read code. If you can't read code, you really shouldn't be attempting to write tests, in my humble opinion. We use JUnit because that's what we do. And what we want to do is we want to have a super fast cycle time. And so we use Roboelectric to help us run our unit tests locally. If you're not familiar with Roboelectric, it's an open source project released by, I think it's Square. And what it does is it takes part of the AOSP and runs it natively on the JVM, right? So you don't need to do the compilation of the class to the DEX and then onto the device. You can just run it all locally. You get super fast times for your unit testing. And obviously that scales up quite nicely to do the integration testing as well in certain cases, particularly if you're making use of mock objects, dependency injection, IOC containers such as Dagger, things like that, right? We actually have our own IOC container because we have been using the idea for a long time. But if you're doing open source development, take a look at Dagger. It's pretty good. And that leaves end-to-end testing, right? I happen to be the creator of WebDriver, which is a pretty popular web testing tool, better known as Selenium these days. And so when I arrived at Facebook and they went, we're not really sure how to do end-to-end testing, it's like, hang on, I've got an idea, lads. This might work. We use Selendroid for our end-to-end testing. This is a product originally out of eBay. The lead is a chap called Dominic Derry. And we contribute to that. We've got active, we have patches that are going in upstream. We're part of that community. We haven't tried to invent everything ourselves, right? We've taken a look at the ecosystem that's out there, and we're trying to support people. Now, Twitter uses Espresso, and the problem with Espresso is that it only supports Jelly Bean and upwards, right? we have to support users who are attempting to use Gingerbread, which is why we're using sort of a sort of slightly more generic tool. But Cell-Android is actually lots of fun to use. We have wrapped it with a page object pattern, by the way. I think some of my colleagues give a talk at other Droidcons about how we use Cell-Android. But there are loads of sort of design patterns to make writing your tests easy and lightweight. Great. So we have in the region of lots of tests. Because we've structured our code base the way we have, because we're using Buck, and Buck knows the inputs to everything that goes in, we can identify which tests need to be rerun for any change of code in any line of code that we change, right? We can go, oh, look, that change has occurred for this particular module, and these tests depend on that module, therefore we will run these tests. How do we do that? We use continuous integration, like I think everyone else does. Hope everyone uses continuous integration. If you're writing tests and not using CI, either you're on your own, which is okay, or you're mad, which is less okay, but still fine. Don't come and find me in my sleep. We use BuildBot as our tool. BuildBot is less a continuous integration system as a toolkit for putting together a continuous integration system. Obviously, we don't use all of these source control systems. This is basically from the BuildBot side. We use a combination of Mercurial and Git, but we have the build master. They watch for changes that are going on, download the latest version of the code, run our tests, keep everything running as smoothly and as cleanly and as nicely as we want. One of the nice things is if you start introducing a failing test, we will notify you by email that you've introduced a failing test. And the other thing that we will do is that we will then disable your test and file a bug for you to fix that. If you don't fix that test in a reasonable amount of time, we delete your test. Now, the reason why we do this is that a continuous integration server is utterly useless if no one trusts the results that come out the back of it. Right? If you are sitting there and your continuous integration server is red, and you turn to your tech lead and you go like, is it okay if I check in? And they go, oh no, yeah, it's always red, that's fine. Totally not fine. You've destroyed the value of it. You might as well just remove all your tests, right? It's better to have a smaller set of tests that you trust, and when they fail, it means something, than to have a larger number of tests that are meaningless, right? So we delete the tests that are flaky, that are unstable, if no one fixes them in time. And we're also pretty cautious about when we introduce them into our builds as well. We have a system that will pre-run all your tests numerous times before we let it into the suite. So we do this sort of automated testing. We've got CI. We're building incredibly fast. How do we release? Well, what happens is over the space of a month, oh no, hang on. It's not a month anymore, is it? It's 2 weeks. We used to have a month, right, because we had a manual process in the middle of our testing step to make sure that internationalization was done correctly. We automated that, and we took a process that used to take a long time, shrunk it down to being effectively instant. And that's allowed us to take our release cycle down from 4 weeks to 2 weeks, and there's still a bit of scope and a bit of wriggle room, so we could go faster if we wanted to. So we spend 2 weeks of development, much like Twitter do. At the end of this 2 weeks, we cut a release branch, and then we spend the next 2 weeks stabilizing that release branch. So there's going to be bug fixes that go in. There's going to be things where we suddenly realize it's not working. We're not afraid to yank features, right? These things come out every 2 weeks because we're doing these sort of time-based releases. Now, the nice thing is that you know that if you miss this release, you're going to be there in 2 weeks' time, right? It's not the end of the world. You're still going to be able to hit your sort of quarterly goals, your targets, and things like that. And what we're finding is that people are calming down a bit around sort of when we cut the release branch. Previously, when we were in a month, over the course of a quarter, you had 3 opportunities to have your feature put out in front of people and verify that it was good. Now you're up to 6. It would be nice if there were more. So we spend about a week and a half stabilizing things, and we give every single person at Facebook who works at the company, not who's on Facebook. No, we don't give it to 1 billion people, obviously. Here, have some wildly unstable software that we think is probably okay. We don't do that, right? But we give Facebook staff the release candidate, and they can try it out. You'll notice that I omitted the manual testing. We don't have a manual QA team at Facebook, right? Everything that we do, we automate, right? With our engineers, if they write a feature, we expect them to be adult enough to be able to maintain that feature and verify that it works. It's kind of childish to go, I wrote it, but you can make sure it works. Like, what? Who does that? Like, you wouldn't trust a cook who didn't eat their food, right? Would you? I don't know. Is that a good analogy here in France? I'm hoping it is. Yeah, like thin cooks can't be trusted. In the same way, developers who aren't responsible for testing their own code could just be writing garbage, right? I can write code incredibly quickly if I don't need to verify it works. So we have no QA team. But there are times where your automated testing doesn't catch everything. You don't think of all the corner cases. You need to verify that it works. And so people are brilliant, right? Like I said, everyone in Facebook has the release candidates on their phone. We're encouraged to file bugs whenever there's a problem. And we do that. We also take advantage of the Google Play alpha and beta channels. There's a sign-up process. We release alpha every single day. So you do get the version that we have on master. And actually, with all the automated testing we do, with the regression fixes that we put in, with continuous builds, that's actually pretty stable. That's a pretty good release. If you're a little more cautious and yet you want like the latest, greatest shiny before everyone else, there's a beta channel. And the beta channel we push out. Because of the scale that Facebook operates at, this gives us a huge amount of data. We get crash logs, we get bug reports, and so we're able to sort of cover the gaps that we have in our testing process using the alpha and beta channel and dog fooding. They're really good, actually. If you haven't tried them, the alpha and beta channel are great. So in this talk, we've covered a lot of the open source that Facebook is involved with, right? One of the key things is we try not to invent everything ourselves. Larry Wall has this concept of like the 3 attributes of a great developer, and one of them is laziness. And it's laziness in the sense of, I'm willing to work really hard, but I'm only willing to do it once and then never again, right? If some other person has developed a piece of open source that fits the niche that we need, that does the things that we need it to, we're going to use it, and we're going to try and be good open source citizens and contribute back to it. So a lot of the open source that we use, JUnit, Roboelectric, Cellendroids, BuildBot, we contribute back to, we provide fixes. Where there's a gap in the market, where we notice that actually there's a tool that could be done better, could be done more efficiently, we've built it, and because we have built our company on open source, we try and give back wherever possible. So our build tool Buck, for example, is a really good example of that. Exo package, I've never seen anything like it in any company that I've worked at, and it's a phenomenal way to allow you to iterate quickly. That's open source, and you can download it. Our code review tools, that's open source. You can play with those as well. We run Facebook on Android on open source, and we wouldn't be able to be the company we are without it. Thank you all very much for listening. I've got some time for questions now. Please wait for the microphone before you ask so that people on the videos can hear your wise words.
Hi.
Hello.
Is there a way to translate your bug make files into Gradle and the other way around, so you can work in Android Studio and it understands the structure of your code and then use your build system that seems more efficient?
No.
Thank you.
There is actually an open bug for that. And there's a couple of ways of approaching it, right? On Friday, I sat down and wrote a tool that converts a Maven project over to Buck. It's incredibly rough around the edges, but with a bit of polishing, I hope to make that available. The thing that we really want, that I would go absolutely nuts for, and it's open source, so please send us patches, and you'll get the commit bit in almost no time at all, is an IntelliJ plugin that enables us to be able to do our builds without having to leave the build tool. Android Studio is based on IntelliJ, right? So if we had that, we'd be able to do it. The other thing that's quite nice, actually, is that because we encourage people to host things in a single tree, it's normally enough to just use IntelliJ's techniques for doing a build, Control-Shift-F10, away you go, to be able to run your unit tests. For the more involved tests, we have a flag for buck test, --debug, and that will start Buck listening on, that'll start the Java debugger listening on port 5005. The other thing we've got is you can run Buck projects, and that will generate your IntelliJ configuration. So although we don't have a plugin, we can set your project up in a way that it feels naturally in IntelliJ, and you can run your code and debug it as with minimal effort on the command line. But yeah, having a plugin would be awesome. And if anyone knows IntelliJ and wants to get involved with the project, do let me know. And yeah, I'll help you get started on the Buck code base, and we'll get your code in super fast. Because we accept pull requests. That's awesome. Thank you for asking. I should have thought about it. Is there any other questions?
I'm a bit curious about your remark about deleting some tests when they are failing for too long. Isn't it risky because this might significate that there is a bug somewhere in the code? So
yeah. So here's the thing: the test is failing. It's providing no value, right? It might be testing something really important, but the test is failing, and you can tell the difference between like a flaky and a consistently failing test. Because if you take a look at the sort of past history of a flaky test, it normally goes like, you know, using the red, green, 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 red, green, red, green, red, green, red, 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 green. And you're going like, that is clearly a test that's flaky. Whereas if someone has introduced an actual failure, what will happen is it goes green, 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 red. Yeah. I once heard someone describe it as like Cylon. Cylon, flaky tests is Cylons, right? Because they've got the thing going across the front, right? I love that description. Yeah, when we file if we see one of these things failing, we file a bug. We normally have someone who's triaging these and just going like, hang on a second, is this flakiness or is this a genuine failure? If it's a genuine failure, we tend to dig in and file a bug going like, hang on a second, here's the actual underlying component that's broken. Whereas if it's just a flaky test, the person who authored the test will just own the issue going like, remove the flakiness, right? And it can be quite hard to tell whether you've written something that's flaky. Like, I wrote a test, and when I was doing TDD on it, it was like green, 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 and then I made no changes, and I went red, green, red, green, red, green, green. It's like, what the heck is going on? And I was writing a zip output stream, because I'm mad. It seemed like a good idea at the time. And unbeknownst to me, the timestamp accuracy of a zip is with 2 seconds. So when I ran the test, on an even number of seconds it would pass, and when I ran it on an odd number of seconds it would fail. And there was absolutely no way to detect that that was the case other than pure chance. So flakiness comes in like all sorts of things. It isn't someone doing a bad job, it's just there are these unforeseen things that happen. Does that answer the question? Yeah. In an incredibly long-winded way.
Hi, you mentioned using a multiple source tree, right?
Yeah.
So did you guys use Git flow, or you come up with your own branching?
We have a single source tree for all of our Android codes. We don't use Git submodules. We just mash everything into that single source tree. We like having hermetic repeatable builds, and so we also check in our third-party dependencies. Like if you're coming from a Gradle or a Maven backend, you're used to like going, oh, I've checked out my code, and then you clamber on a plane and you go, and now I'm going to build it, and you go like, crap, right? Companies with a with a single nexus, have taken what should be a distributed process, each developer has everything on their machine, and introduced a single point of failure for added hilarity and coffee breaks, I assume. So we check in our third-party dependencies and all our code to a single source tree. Obviously, there is a concern that that gets quite big. First of all, disks keep on getting larger. Like, I remember when like terabyte disks were pretty popular, and then we moved off spinning platters and onto SSDs, and it was like, oh no, only got 128 gigabytes, which is big enough for several virtual machine images, a huge code base, several builds, blah 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 blah. Nowadays, like these machines have quarter of a terabyte, half terabyte disks are coming back again. Disk space is relatively cheap. Network bandwidth also relatively cheap, which is why we can use the caching approach that we do. And the argument about like, yeah, but if I have to check out my third-party dependencies, that's like a waste of disk space. It's like, so what? We live in the bloody 21st century, right? We're not limited these days. Like, disk space is a scarce resource, is a problem that we have managed to just outlast, right? Like, disk has got big enough. So, yeah. I don't think I answered your question.
Yeah, you skip it.
I skipped it. Would you like to ask it again, and I'll pretend that I'm paying attention?
What's your branching convention? Is it like a Git flow branching convention, or something you come up internally with?
Okay, I beg your pardon. So the branching convention we follow is master is a single linear history of logical changes, and each developer does local branches that they never push into the central repo. The code review tool, Fabricator, takes patches and presents them as a sort of unified change. And then when we're ready, what we do is we squash all the individual commits down to a single change and merge that one change back into master. So that's the developer workflow and the local machine, right? What that means is that any person can go and take a look at the history of master, and without needing to be a Git ninja, which some people have to become, but nobody wants to be. Do they? I don't know, maybe they do. Without needing to be like a master of distributed control systems, source control systems, they can take a look and see like what's gone on here, rather than like also developers, when they're just doing local commits, will go like, I go like CP for checkpoint, right? And I know what's going on, but someone who looked at those, if I were to merge all those into the tree, would just sit there going like, he's written garbage. Which is true, but like I'd like them to think that I'm a professional developer, right? So we squash all of them down and push them into the single thing. With the releases, we cut a single release branch, and then that stays live for 2 weeks. Changes always happen on master, and then they're cherry-picked into the release branch. That's to prevent us fixing a critical bug and forgetting to put it on master and having to fix it like repeatedly, like, the horrific world that some people get trapped in. So yeah, those are the kind of two models we follow. But basically, master is a single linear history. Okay, I've probably got time for like one more question, I think. Has anyone got like a fantastically difficult one? What is a directed acyclic graph? I don't know. Okay. Well, in that case, I'm going to be around here. Some of my colleagues are down at the front. If you've got any questions about open source or the work we do at Facebook, particularly in London, come and have a chat. It's a great place to work. Thank you all for your time.